Okay, if a solution was dark pink in phenolphthalein, what color would it be in methyl orange? So in your data booklet, you've got the pH that it changes from and to. It would probably be a good idea to write in your data booklets that low pH means it's acid and high pH means it's base. So you need to start decorating your data booklet. So if it's dark pink, then it must be basic. So methyl orange would be yellow. Okay, this is so clunky. The graphs that we're looking at, these graphs, which are a classic kind of multiple choice question, show the pH curves for titration involving combinations of acids and bases of various strengths. So decide if phenolphthalein or methyl orange indicator would be suitable to identify the equivalence point for each reaction, A to D, or if neither. Provide reasons. Identify either strong or weak acid or base, and which was the aliquot and which was the titre. So when you're measuring the pH, they put a pH meter in here. So before you start the titration, when the volume, so you're adding acid here, acid's being added, and so the pH meter that's in here is measuring at 0 time, it's measuring 14, so it's measuring a base. So there's a base in here for this particular example. Acid here. It's hard to look at the screen and write at the same time. Alright, so you have to work out which indicator. So when it starts, it's a strong acid because you've added a lot of strong base, sorry. You've added a lot of acid and it hasn't changed the pH much. So it's staying up in the basic region. So if it stays up here, then it's a strong base. So by the time you get from pH 14 to pH 13, which is about here, the reaction's pretty much finished. And then these are log scales, so going from 13 to 12 is 10 times less the strength of the base and the amount of acid that you need, and then it's 10 times less, 10 times less, and so you're almost there. So this is when you're on this side of the equivalence point, you've got too much base, and when you're on the other side, you've got too much acid. So acid plus a base makes salt and water. So you started off with lots of base, and then as the reaction's going, you're slowly adding acid until eventually you have exactly the same amount. So there's no more acid, there's no more base, and you just have salt and water at the equivalence point. So because water itself makes hydronium ions, you still have a pH. You still have a concentration because the pH scale is measuring the concentration of hydronium ions. So even at 7, just because there's water there, you still have a pH. So after this point, you're continuing to add acid. So now you've got too much acid. So the pH, instead of just being salt and water from now on, you've got more acid, which is why the pH is coming down here. So if it's a straight, if we could stretch this graph right out, you would see that that line there is actually tilted slightly, but because it's here, you can't see that it's on an angle. So we want to find basically the middle point of the straight line, and the middle point is at where you have equal amount of acid and base, and so you want to find an indicator that changes color across there. So both of these, 7, 8, 9, 10, phenolphthalein changes color across here, and 3 point, I should write numbers on here, 1, 2, 3, 5, 6. So between 3 and 4 here, methyl orange changes color across here. So either one of them you could use. Bromothymol blue changes color right across the middle. So any of them, because We call this a sharp endpoint where it changes color. So you're adding acid, adding, and you add a tiny drop to go from here to here, just a drop, and all of a sudden the pH has changed really quickly. So the color, as you're going from pink to clear for phenolphthalein, from base pink to clear. So it's hot pink up here, and then all of a sudden it'll be clear, and you've only added a drop. So we call this color change, when it's straight up and down, a sharp end point. When the line's straight up and down, it's a sharp end point. So that's what you're looking for. You've only added a little bit of acid and the color changes really quickly. So in that case, then you could use either indicator, because they both have sharp endpoints. They use the word sharp when, quick would have been a better word, but anyway. So the aliquot, what you started off with in here was the strong base, and what you ended up with, what you were adding, titre. So just read the bottom scale here. What you're adding is a strong acid. Okay, this one you can see instead of staying up in the basic region, in fact it's not even, it's 13, 14, 12, it's a bit over 11 to start with, so it's not very basic to start with, and then it's kind of floppy, it doesn't really stay straight up here. So it's clearly a weak base. And another way of working it out is your middle point. If you look at the straight line, the middle of your straight line, it's below 7. So you end up, the reason that you end up down here when you've got just a salt and water is because the salt that you make for these are actually a weak acid themselves. So we don't need to go into too much detail, but if you have a strong acid and a weak base, whatever the strong thing is, you'll end up with a weak salt of the same type. So you end up with a weak acid salt. So the salt and water that you make, the salt is actually acidic, so it's lower. So you want something that changes color around this region, and if you look up methyl red, it changes between 4.4 and 6.2, so you need something that changes around there. Okay, this one. Okay, so this is the opposite. You can see it's staying up in the basic area, and then your midpoint is above 7. So if it's in the basic, it must have been a strong base and a weak acid. So the acid is it's adding the same amount of hydrogens, so the reaction will still come to completion. It's just that the hydrogens aren't floating around in the water the whole time. They're just being given one at a time. So you don't have a lot of hydronium to measure. The hydrogens are still there, but they're attached to the acid. You can't measure them because they're not they're not hydronium. So you need something that's going to change color, so phenolphthalein is a classic one. And this one, so all of those ones that we've looked at so far have had a sharp endpoint, a quick endpoint, as in you add a little bit of acid and the color will change. These ones, the color is kind of changing for a long time, so it's going from hot pink, if it was phenolphthalein, hot pink would be up here somewhere. That's kind of going slowly clear. Might be, yeah. So it would be changing here actually. Phenolphthalein would be changing here. It would go from hot pink to clear. If you use bromophthalmol blue, it would be changing. I can't remember the colors, but it would be changing. You'd be adding a lot of acid, and it would be slowly changing color. So you wouldn't know when to stop. You wouldn't know at what point along here you should stop. So it has a broad end point, and basically you couldn't do a titration with this if you've got a weak base and a weak acid. Okay.